Concepts of acids and bases. What comes to mind when one mentions an acid? A substance that is dangerous or corrosive, capable of killing. Are there useful acids? These and other questions shall be answered by the end of this lesson. By the end of this lesson, you should be able to 1. Differentiate between an acid and a base. 2. State the differences between a strong acid and a weak acid. 3. Given two bases, how will you determine which is a strong base? Let's begin with a definition of acids and bases. What is an acid? Initially, scientists considered substances that have sour taste as acids. Therefore, vinegar and unripe citrus fruits such as grapefruit and orange that taste sour were considered to contain acids. Swedish chemist Svante Arrhenius defined an acid as a substance that dissociates to produce excess hydrogen ions, H+, in aqueous solution. That is, an acid ionizes in aqueous solution to increase the relative concentration of hydrogen ions. Generally, the equation for the dissociation of an acid, HX, is illustrated on your screen. For example, hydrochloric acid, HCl, dissociates in aqueous solution to produce hydrogen ion, and therefore it is termed as an acid. The diagram on your screen illustrates how water molecules, hydrogen ion, and chloride ions coexist in solution. He also defined a base as a substance that dissociates to produce excess hydroxide ions, OH-, in aqueous solution. That is, a base ionizes in aqueous solution to increase the relative concentration of hydroxide ions. The general equation for the dissociation of a base MOH is illustrated on your screen. For example, aqueous sodium hydroxide, which is a base, dissociates to produce sodium ions and hydroxide ions in solution. Since sodium hydroxide dissociates to produce hydroxide ions in solution, it is considered as a base. Thus, acids increase the concentration or amount of hydrogen ions in aqueous solution, and a base increases the concentration of hydroxide ions in aqueous solution. The diagram on your screen illustrates how water molecules, sodium ion, and hydroxide ion coexist in solution. This definition limited the scope of acidity and basicity to only aqueous solutions. There was the need to broaden the scope to include non-aqueous solutions. As a result, Bronsted and Lowry proposed a more acceptable definition, which is accepted by examiners. They defined an acid as a substance that donates a proton in acid-base reactions, and a base as a substance that accepts a proton. The HCl molecule dissociates or ionizes and donates its proton to water. Therefore, HCl is acting as an acid. Water accepts the proton to form H3O+, and hence it acts as a base. Let's now continue with the types of acids and bases. Acids and bases can be classified based on their strength. The strength of an acid or a base is a measure of the extent to which it dissociates or ionizes in aqueous solution. A strong acid is the acid that ionizes completely or almost completely in aqueous solution. The general equation illustrating the ionization of a strong acid HY is illustrated on your screen. For example, HCl dissociates to produce H+ and Cl- ions in solution. The single arrow symbol means the dissociation is complete and therefore the reaction is irreversible. The diagram on your screen illustrates how hydrogen ions and chloride ions coexist in solution. Examples of strong acids are mineral acids such as hydrochloric acid HCl, tetraozosulfate 6 acid H2SO4, triozonitrate 5 acid HNO3. Other features of strong acids are: 1. They conduct electricity strongly and therefore are considered as strong electrolytes. An electrolyte is a substance that conducts electricity and undergoes a chemical change in the process. The diagram on your screen illustrates how the positive ions and negative ions from the acid move to the opposite electrodes to conduct electricity. Two, they react vigorously with some metals. 3, they have low pH values below 7, that is within the range of 1 and 3. On the other hand, weak acids ionize partially in aqueous solution. The general equation illustrating the ionization of a weak acid HY is shown on your screen. For example, aqueous hydrofluoric acid HF, which is a weak acid, dissociates to produce hydrogen ion and fluoride ion in solution. The double arrow symbol means the dissociation is partial and reversible. That is, as some HF dissociates to produce H+ and F-, some H+ and F- ions recombine to form undissociated acid again. The diagram on your screen shows how undissociated acid and hydrogen ions as well as fluoride ions coexist in solution. Other examples of weak acids are hydrofluoric acid, HF, triosocarbonate 4 acid, H2CO3, tetraosophosphate 5 acid, H3PO4, organic acids such as methanoic acid, HCOOH, and ethanoic acid, CH3COOH. Other features of weak acids are they conduct electricity weakly and are therefore considered as weak electrolytes. They react slowly with some metals. They have high pH values below 7. Let's now move on to strong bases. Similarly, strong bases ionize completely or almost completely in aqueous solution. The general equation illustrating the ionization of a strong base, MOH, is shown on your screen. For example, potassium hydroxide dissociates completely to produce hydroxide ions. The diagram on your screen shows how potassium hydroxide dissociates to produce potassium ion and hydroxide ion in solution. Other features of strong bases are they conduct electricity strongly. They have high pH values above 7. On the other hand, weak bases ionize partially in aqueous solution. Example is ammonia, NH3. Other features of weak bases are they are weak electrolytes. They have relatively low pH values above 7. Let's now take a look at what we've done in today's lesson. Vinegar, citrus fruits, etc. contain some acid and therefore taste sour. Acids are proton donors in acid-base reaction. Bases are proton acceptors in acid-base reaction. Acids increase the relative concentration of hydrogen ions in aqueous solution. Bases increase the relative concentration of hydroxide ions in aqueous solution. Strong acid or base dissociates completely or almost completely in solution, while weak acid or base dissociates partially in solution. Acids and bases are electrolytes. Strong acids and bases are good conductors, while weak acids and bases are weak electrolytes. All too soon, we've come to the end of our first lesson for the year. See you some other time. Until then, it's bye.